Welcome to the 9th lecture in Riparian Function and Management. In our last lesson, we introduced the role of riparian vegetation in buffering to the soil-water balance and providing for water storage. If you will recall, vegetation is the key and often the one thing within our management control. Vegetation determines whether you have a watershed or a water catchment. It's the difference between function and dysfunction, and between sponge versus no sponge. We can understand riparian vegetation by understanding a plant's stability rating and wetland indicator status. Regardless of the types of vegetation that you have, be it woody or herbaceous, sedges and rushes, grasses, forbs, or trees, it plays a special role in riparian areas. Plants can also be considered by their functional groups: pioneer species, early and late-stage colonizers, or strong-rooted stabilizer plants. In this lesson, we will look at vegetative indicators of riparian function. Key vegetative considerations center around plant presence and plant health. Is the area covered with plants? Are they expanding? Is there a community of strong stabilizers to provide a stabilizing root mass? Are they present and are they capable? If the system requires large wood and not all do, is there a source that can become incorporated into the beds and banks? Are the plants healthy? And the vigor, is it overgrazed or overbrowsed or overmowed? Is there a diverse plant community in terms of species? Are plants of different ages present, some old, some middle-aged, but also some young or new plants? Do the plants tell you that there is water present, or are they indicative of wet conditions, an obligate and facultative wet species? One of the first considerations is there enough plant cover in the riparian area? Generally, we are looking for a coverage of 70% or more with important riparian plants. You'll recall that the definition of a functional condition hinges on enough stuff to dissipate energy, and vegetation is a huge component of the stuff that holds streams together and ensures that they keep producing the values that we want. Clearly, this drawing is designed to illustrate an ideal vegetation condition for riparian areas. We seldom find ideal, but all sites are in the process of becoming more or less functional. Next, are the plants expanding and are they colonizing and holding new sediments? Fresh sediment is usually rich in organic matter, the key to water storage and riverbanks. This photo shows knotgrass, which is sending runners into the channel. They stabilize the bank while catching sediment and debris. Knotgrass is good at this, but there are many others that use their colonization traits to narrow channels and to expand wet banks. Here, it's the little spike rush. We've all seen it before. It's a great example of a colonizer and a stabilizer expanding along a stream's edge. Here is a water willow. This is a plant that many people actually dislike. You can see it here marching into the channels and putting down root mass. Is there stabilizing vegetation present, and is it healthy? Stabilizing vegetation includes plants with stability ratings around 6 and 7. These could be trees, grasses, or sedges. Stabilizing channels, banks, and floodplains can do a great deal toward improving water quality and water quantity. One of the primary attributes of good riparian vegetation is the extraordinary root systems of many riparian species. These root systems are what help to reinforce banks and floodplains during flood events. Not only must roots help protect against the erosive effects of moving water, but it's also common to have large rocks and logs moving downstream during flooding. Vegetation must be well off enough anchored to resist these powerful forces and to withstand a high flow event. Above ground biomass is an important characteristic of riparian stabilizer plants. Above ground growth helps to dissipate the energy and velocity of floodwaters, which allows some sediment to drop. The plants then stabilize those newly deposited sediment and gravel, helping to build bigger and more effective floodplains. The water storage capacity of these enlarged floodplains, or the riparian sponge, is also enhanced, which in turn helps to sustain base flow. Here is a chart comparing the upland plants and the riparian plants in terms of root length per cubic foot of soil. Riparian plants are highly specialized. Typically, they have at least 10 times as much root length per cubic foot of soil than upland species. Per the root's biomass, a pound of roots per acres are 2 to 5 times greater than their above-ground leaf and stem biomass. Compared to common upland plants, this chart compares some key stabilizers. These include deergrass and Baltic rush as some key colonizers, such as spike rush and knotgrass. During floods, trees can get washed out or will break off and can become lodged in the channel or floodplain, thus playing an extremely important role in initiating and sustaining riparian stability. For many years, this valuable contribution to stream stability was not recognized. People thought that they needed to remove the large wood and debris and that they were cleaning out the channel. But we now know that the presence of large wood is very important in the channel and for bank stability. And many engineered projects actually use dead trees in logs and their designs. It's important for people to become comfortable with the unkept and messy appearance of downed trees on the banks and protruding into channels. Here, the root wad of fallen trees is incorporated into the natural restoration process. This fallen tree is providing a place for new plants to get started or to colonize, and slowly it is becoming buried within the channel. For plant vigor, are your plants healthy? In the photo shown here, their vigor is quite compromised. When woody plants begin to produce scabs from repetitive overbrowsing, and when not necessarily palatable grasses are continually cropped short, it's time to look for causes and to find ways to address those hindrances. You can determine a plant's root health by its vigor. Notice how a vigorous plant in its natural state has an extended, dense root system. However, when plants are grazed or mowed, their root length and density will diminish. Constant grazing or overuse will transform a healthy, densely rooted plant into having practically zero root stabilizing capability. Only when riparian vegetation is healthy and vigorous can it contribute to function. On most creek and river systems in Texas, livestock and wildlife grazing or browsing is the most important factor that influences riparian vegetation. Heavy grazing or prolonged grazing damages riparian vegetation, and it renders it ineffective at building and holding new banks. Riparian vegetation works together as a community with different plants, all performing compatible and complementary work. It is important to have a diversity of riparian plants present. Here, we can see spike rush, or switchgrass, sycamore, and baccharis. Next, you would expect to begin to see some of the stronger stabilizer plants showing up, such as sawgrass and buttonbush. This site clearly lacks diversity. Cypress trees are very good stabilizers, but alone, they cannot do all of the work needed to achieve and maintain a functional riparian area. If you look closely, you will see clues to a possible hindrance. Just downstream on this very same creek, the cypress trees are joined by eastern gamma and other strong riparian plants. This site hosts the diversity required to withstand and benefit from floodwaters. In this diverse and healthy setting, you can see emery sedge, black willow, and water willow. Multiple types of riparian plants seen here include grasses, sedges, forbs, and woody plants. Another important consideration is the age diversity of riparian plants. Here you can see both mature and new switchgrass plants. On the near bank, you can see both mature and young cypress trees. However, on the other side of the creek, age diversity is limited. Activities seem to be limiting the recruitment of young trees. Finally, important information can be learned about the health of a riparian area by examining the wetland indicator status of the plants growing there. For instance, if obligate and facultative wet plants are present, then water is being stored and a riparian sponge is probably present year-round. Today's lesson covered some of the key considerations in understanding the riparian plant community. The considerations we discussed help answer the following key questions. Are the right plants present, and are they healthy? For homework, you are asked to visit your chosen creek site and identify key riparian plant species. You may find your remarkable riparian field guide very helpful in this assignment. You need to find and ID at least 3 grasses, 3 forbs, and 3 woody plants. Document these plants and document their SR and wetland indicator statuses and any other information that you can gather about their age and vigor in your data log. Be prepared to discuss your findings.